Imagine the world without electricity. No lights, no phones, no internet. It's hard to imagine, right? But how does this essential force actually work? Today, we're tackling electricity, a vital chapter for your Class 10 CBSE physics exam. We'll define what it is, why it's so crucial for your CBSE studies, and how much weightage it carries in the exam. Expect plenty of questions from this chapter. Let's begin with electric current and circuits. Firstly, electric current is the rate at which electric charge flows. Secondly, circuits provide a closed, continuous path for this current to move. And finally, a battery or cell is what provides the necessary voltage or push to keep the current flowing. Electric current is the rate of flow of electric charge through a conductor. It's like measuring how much water passes through a pipe every second. We measure it in amperes, often shortened to just A. Now, let's talk about potential difference and how it relates to current. Potential difference is what drives the current, and Ohm's law gives us a mathematical relationship, V equals IR. Where V is the potential difference, I is the current, and R is the resistance. Remember the units too. Ohm's law is V equals IR. V stands for potential difference, measured in volts. I represents current, measured in amperes. And R is resistance, measured in ohms. Use this formula to find voltage, current or resistance in a circuit. Next, we have resistance. Resistance is what opposes the flow of electric current. Think of it like friction. Higher the resistance, the less the current will flow for a given voltage. Resistance depends on the material of the wire and its temperature. The formula for resistance is R equals V divided by I. R is resistance, V is voltage, and I is current. Always remember that resistance is measured in ohms, represented by the Greek letter omega. Here's a key point to remember for your exams. Voltage is the cause asterisk, it pushes the current through the circuit. Current is the effect asterisk, it's what actually flows. Also, remember the difference between series and parallel circuits, as examiners love to test you on those. Let's solve a typical exam question. A 6 volts battery is connected to a resistor, and the current flowing is 0.5 A. What's the resistance? First, use Ohm's law, R equals V divided by I. Then, substitute the values, R equals 6 volts divided by 0.5 A. That gives us a resistance of 12 ohms. Let's look at a real-world example, electric heaters. These use a high-resistance wire that heats up when current flows through it. This is based on Joule's law of heating, a key concept in your syllabus, and it's used in toasters, hair dryers, and many other devices. Here are a few exam tips to keep in mind. Always include the correct units in your answers. Examiners are very particular about that. Make sure you apply Ohm's law correctly. And finally, practice drawing circuit diagrams as they are frequently asked in exams. So, let's quickly recap what we have learned. Firstly, electric current flows through circuits because of the voltage. Secondly, Ohm's law helps us understand the relationship between voltage, current, and resistance. And finally, resistance opposes the flow of current, which can generate heat. And remember, all of this, including AI-powered notes, doubt solving, and unlimited practice tests for electricity, is available for free on Synapse. Study smarter, not harder, with the power of AI. Start your free learning journey today by visiting synapse.omups.in. Master electricity for your CBSE exams. And don't forget to subscribe to our channel for more free lessons. Visit synapse.omups.in and start learning today.